Hi everyone, this is part 2 of the notes for inductive reasoning, and we're continuing with number patterns, example 4. Look at the pattern 2, 4, 6, 8, 10, ... that means it continues. What's the 19th term in the pattern? So 2 would be the first term, 4 would be the second term, 6 is the third, and so on. And then part B, describe the pattern to try to find an equation that works for every term in the pattern. Alright, so let's rewrite this. So what's happening when I go from 2 to 4? I'm adding 2. 4 to 6, adding 2. So this is the pattern. Take the number and add 2 to it to get the next term. Recognizing the pattern is really the first step. First term is 2. So 2 times 1 would give me 2. The second term, I get 4. So if I take 2 and multiply it times 2, that would give me 4. Third term, I get 6. So how can I get what numbers would give me 6 here? So it would be 2 times 3. So these 2's are always the same right here. I'm always multiplying by 2, and these numbers are actually the term. So the first term is 1, 2 times 1 is 2, the second term is 2, 2 times 2 is 4, the third term is 3. So what would the 19th term be? So 19th term would be 2 times 19, 38. So that's part A. Part B says define an equation. Let's let n equal the term number, and y can be the number in the pattern. So what do we do here? Y is going to be equal to, we take 2 and we multiply that times whatever the term is. So that's it, 2n. So if I were to put in 19 in for n here, it'd be 2 times 19 is 38. Okay, example 5. Look at the pattern 1, 3, 5, 7, 9, 11. What is the 34th term in the pattern, and what is the nth term? Basically, this is asking us what's the equation for the nth term. Okay, so the pattern is increasing, isn't it? By the same number. It's increasing by 2. But all these numbers right here are odd. The pattern increases by 2 and is odd. So I hope you see that when we are increasing by a number, it ends up being multiplication in our equation. And in this case, we're increasing by 2. So if let's call n's our term number, so this would be our first n, this is our second, third, fourth, etc. So I've got, let me write down, make a little table here. Okay, so my first term, increasing by 2 again, so I think I have to multiply by 2. So what happens if I multiply 2 times n? Because I'm increasing by 2 here. That's what we saw in the last problem. So what would 1 times 2 be? Well, that would be 2. 2 times 2 would be 4. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. But these are all even numbers. I need these to be odd. I need 2 to be 1. I need 4 to be 3. I need 6 to be 5. So what are we doing here? We need to subtract something, don't we? We need to take 1 away. So 2 minus 1 would be 1. 4 minus 1 is 3. 6 would be 5, 8 would be 7, and 10 would be 9. Okay, so there's our pattern. We take the number of terms, we double it, and then subtract 1 from it. So what would the 34th term be? 34. Okay, so we would first need to double that. That would give us 68. And then we subtract 1 from 68. It would be 67. So that would be our answer, 67. So we need to say that we're going to let n equal the term, and y is the number in the pattern. Okay, so what do we do? To get y, we have to take, what do we do to n? We have to double it. So 2 times n, and then we have to subtract 1. Okay, 2n minus 1, that's part B. Okay, so example 6. Look at the pattern, 3, 6, 12, 24, 48. What is the next term in the pattern? What's the 10th term? Make a rule for the nth term. Okay, so this would be the first term, second term, third term, fourth term, fifth term. So let's write that down. 1, first term, second, third, fourth, fifth. And I get 3 is my pattern. I get 3 out of it. And the second one is a 6. And then it's a 12, 24, 48. So if you notice here, we are not increasing by the same number each time. Like to go from 3 to 6, you could say, okay, well, just add 3. But then immediately that pattern is broken going from 6 to 12 because we're not adding 3, we're adding 6. So just multiplying by a number that we did in the first couple of examples is not going to work for this. So let's think about what the factors are in this pattern. So the factors of 3, so that's 3 times 1. So what are the factors of 6? Well, 6 and 1, or 3 and 2. And the factors of 12. Well, let's continue with this 3 idea here. Maybe 3 is a factor of all of these in the pattern. So 3 times what is 12? 4. 24. 3 times what would give us 24? 8. 3 times what here for 48? 16, right? 3 times 16 is 48. So how can we rewrite? Okay, so we have 3 we're using 3 for all of these. So I'm going to rewrite this out front. 3, 3, 3, all the way down, times. So how can we rewrite 1, 2, 4, 8, and 16? Do you see the pattern here going from 1 to 2 to 4 to 8 to 16? How can we rewrite this as an exponent? So 2 to the second, I know 2 to the second is 4. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the first would be 2. And 2 to the 0 would be 1. So we can say 2 raised to the 0, 2 raised to the first, 2 raised to the second, 2 to the third, 2 to the fourth. So on my first term here, I did 3 times 2 to the 0. On my second term, I did 3 times 2 to the first. So on my 10th term, so we could see the pattern here. On the 10th term, I'm going to have 3 times 2. So can we see the pattern? Like this is 1, this is 0, 2, 1, 3, 3, 2, 4, 3. So if I'm going to do 10, I have to take 1 less. So this would be 2 to the 9th. 3 times 2 to the 9th. Or let me write it this way. So we're taking to the 10 minus 1, right, which is 9. So this would be 3 times 2 to the 9th, which is 1536. So my pattern here would be 1536. All right, so that might seem like a little much, but when we're clearly not adding the same number here. So we're doing something that has multiplying by the same number. And whenever we multiply by the same number from one consecutive term to the next, what we are doing is we're raising to an exponent. So let's take a look at the rule here for this. Y would be, so what do we do here? We take 3 and we multiply it times what? 2 raised to the n minus 1. And that would be our answer for part B. Okay, we have one more type of example to look at, and this has to do with fractions. So, example 7, find the 8th term in the list of numbers as well as the rule. With fractions, we want to separate the numerator and the denominator. I've got, so 2, and we can write this as 2 over 1. That might be useful. 2 over 1. And then 3 over 4. So 3/4, 4/9, 5/16, 6/25. So we can see the numerator is just increasing by 1, but the denominator is not just increasing by 1. Something else is happening down here. So let's see if we can figure out what this is. So for the, let's say that for the first term n, first, second, third, fourth, let's do a couple of these. 5th, 6th, 7th, let's say 8, let's go up to 9. So what's happening on the first term? We get what? We got 2 over 1. And then we get 3 over 4. And then 4 over 9. 5 over 16, 6 over 25. What would the next one be here? It'd be 7 over what? What's happening here? 1, 4, 9, 16, 25. These are all perfect squares. So what's the next perfect square from 25? 36. So these would be 8 over, what's the next perfect square? So isn't this 1 squared right here? So this is 2 over 1 squared. Let's do this in different color. Let's do it in some green. This is 2 over 1 squared here. This one is 3 over 2 squared. So I can rewrite 9. That would be 3 squared. Okay, so here's the pattern. 4 squared. We're just now counting consecutively and squaring the number. So this is 6 over 5 squared. Notice 5 is the same as the term 5. 6 here. 6 squared. 7. So this would be 8 over 7 squared. 9 over 8 squared. And 10 over 9 squared. So let's say that would be, so we're asked to find 8th term. So here we are. Here's the 8th term. So this would be 49 here. So 9 over, what's 8 squared? 81. 9 over 81. So that's our answer here for the 8th term. Let's just do 9 here. This would be 10 over 9 squared. It's 81. Okay, so what's the rule here? So y equals, so if this is n right here, what's going on in the denominator? If n is 1, then my numerator. If n is 1, my numerator is 2. If n is 2, my numerator is 3. If n is 8, my numerator is 9. So I have to take my n and do what to it in the numerator? Add 1. Divided by, in the denominator, if n is 1, my denominator is 1 squared, if n, which is 1. If n is 4, my denominator is 4 squared, or 16. So all I have to do is take n and square it in the denominator. And that's my answer there. That's my rule. Okay, so let's summarize here. Okay, so if the same number is added from one term to the next, then you multiply n by that number. If the same number is multiplied from one term to the next, then you would multiply the first by increasing powers of this number. In our examples above, we used n or n minus 1 as the exponent. If the pattern has fractions, then separate the numerator and the denominator into 2 different patterns. Find the rule for each separately. Right. Okay, if you got this, move on to part 2.